This is Grade 6 Math, Chapter 1.3, Common Factors and Multiples, Part 1. There are two main ideas in this chapter. The first is to find the common factors and greatest common factors of two whole numbers. That's what we'll be covering in Part 1. The second idea, which we'll cover in Part 2, is to find the common multiples and least common multiples of two whole numbers. Let's begin. Let's start with finding the common factors of two whole numbers, 12 and 30. We'll start by listing the factors of 12. We can take 1 times 12, 2 times 6, and 3 times 4, all to equal 12. Those are our factors of 12. Now let's find our factors of 30. Once again, beginning with 1 and working our way up. 1 times 30 will give us 30. 2 times 15 also equals 30. 3 times 10 equals 30. And there's 4 does not fit in equally, but let's try 5. Yes, 5 fits into 30 6 times. So here are our factors of 30. 1, 2, 3, 5, 6, 10, 15, and 30. Now that we've listed the factors of each number, let's find the factors that each whole number has in common. Well, both 12 and 30 have 1 as a factor. They also each have 2. They also have 3 in common. And 6. They have 6 in common as well. So the common factors of 12 and 30 are 1, 2, 3, and 6. Let's try another example together. Use the lists of factors to the right to find the common factors of 10 and 28. The factors of 10 are 1, 2, 5, and 10. The factors of 28 are 1, 2, 4, 7, 14, and 28. What factors do 10 and 28 have in common? Only 1 and 2. So the common factors of 10 and 28 are 1 and 2. Try these next 4 sets of numbers on your own. Find the common factors for each pair of numbers. List your answers in your homework notebook. Show me all your work, including finding the factors for each individual number and then making a list of the common factors. Now let's explore finding the greatest common factor for two whole numbers. The greatest common factor is the common factor that the two numbers share that is the highest in value. There are 3 possible methods for finding the greatest common factor. In method 1, we use the same technique that we used to find the common factors in our last 2 slides. We'll simply repeat that process here to find the greatest common factors. So we're going to find the factors of 45 and 75. The factors of 45 are 1 times 45, 3 times 15, and 5 times 9. Our factors of 75 will be 1 times 75, 3 times 25, and 5 times 15. Now we'll go through and find our common factors. They're 1, 3, 5, and 15. Which of these common factors has the highest value? It's 15. So our greatest common factor between 45 and 75 is 15. Now let's learn method 2. Method 2 uses prime factorization to help us find the greatest common factors. So let's find the prime factors of 45. You can do this using whichever technique you prefer. I tend to prefer the bookshelf method, so I'm going to use that. Let's see. My least prime factor is going to be 3, and 3 goes into 45 15 times. My least prime factor of 15 will also be 3. leaving me with 5, and there's my prime factorization, 3 times 3 times 5. Now let's find the prime factors of 75. 3 is going to be our least prime factor, so 3 goes into 75 25 times. Our least prime factor of 25 will be 5, leaving us 5. So our prime factorization of 75 is 3 times 5 times 5. Our next step is to find the prime factors that both 45 and 75 have in common. Each have a 3, and each have a 5. So we'll find the greatest common factor by multiplying the common prime factors together. 3 times 5 gives us 15. So using method 2, which is the prime factorization method, our greatest common factor between 45 and 75 is 15. Now let's learn method 3. Method 3 also uses prime factorization. However, method 3 has you factor both numbers at once. Let me show you how it works. It utilizes this bookcase method for finding prime factors. However, instead of only entering one number, you enter both numbers that you're working with. So we'll begin by looking at 45 and 75 and finding the least prime factor that they have in common. That won't be 1, that won't be 2, it will be 3. Now we divide each number by 3. 3 goes into 45 15 times, and into 75 25 times. Now we look again. Is there a prime factor that 15 and 25 have in common? Yes, there is. It's 5. 5 goes into 15 3 times, and into 25 5 times. Now, however, we stop. 3 and 5 have no common factor other than 1, so we're finished. We complete our steps now by taking our two numbers on our side here and multiplying them together. 3 times 5 equals 15. So our greatest common factor using method 3 is 15. As we move into the guided practice problems, I am going to ask you to use all three methods, 1, 2, and 3, simply to ensure that you understand how they work and how to use them. However, in the future, you're welcome to use whichever method works best for your brain, as long as you're able to show me all of your work so I understand your thinking. Let's work through one more example of finding the greatest common factors using method 1, 2, and 3. In this example, we're going to find the greatest common factor of 20 and of 32. In method 1, we simply factor 20 and 32. The factors of 20 are 1, 2, 4, 5, 10, and 20. The factors of 32 are 1, 2, 4, 8, 16, and 32. The common factors of 20 and 30 are 1, 2, and 4. The greatest common factor is 4. Let's try method 2. Now let's find the common factors between 20 and 32 using the prime factorization method. So first, we'll find the prime factors of 20. Let me actually step you through it like this problem does not. Since I used the bookcase method last time, I'll use this method. So, our first least prime factor is 2, which leaves us with 10. Carry down our 2 so we don't forget it. The least prime factor of 10 is 2, and 5. 5 is prime, so our prime factorization of 20 is 2 times 2 times 5. All right, now let's try 32. Our least prime factor of 32 is 2, leaving behind 16. Our least prime factor of 16 is also 2. Carry down that 2 so we don't forget it, leaving us with 8. Carry these 2's down so we don't lose them. Least prime factor of 8 is 2, leaving behind 4. Bring down all these 2's. And finally, our least prime factor of 4 is also 2, leaving us with 2 behind, which is prime. So our prime factorization of 32 is 2 times 2 times 2 times 2 times 2. Our greatest common factor is 2 times 2, or 4. So the greatest common factor of 20 and 32 is 4. Now let's try method 3. Finally, let's do this same problem using method 3. Remember, method 3 lets us work with both factors at the same time. So I'm going to write 20 and 32. I'm going to place them in that bookcase. Their least common prime factor is 2. So now I'll divide each digit by 2, giving us 10 under our 20 and 16 under 32. Once again, I'll look for the least prime factor that 10 and 16 have in common, and once again, that will be 2. Once I divide that in, that gives us 5 and 8. 5 is prime and does not fit equally into 8, so they do not share any factors other than 1. So what we have left here is 2 times 2 equals 4, giving us our greatest common factor. Now try this on your own. You may use whichever method you prefer, method 1, 2, or 3, to find the greatest common factor of each of these pairs of numbers. Please record your information in your homework notebook. Hit pause, and I'll be here waiting with our next idea when you're done. Our next idea is to use the greatest common factor with the distributive property. Hold on a second. We'd better stop and define distributive property before we move on. The distributive property tells us that 4 times 3 plus 5 gives us the same answer as 4 times 3 plus 4 times 5. Let's work it out so I can prove to you that it's true. Usually following the rules of order of operations, we would add what's inside the parentheses first, getting 8, and then multiply by 4. Whenever you have a 4 right next to a parent like this, it's telling you to multiply. 4 times 8 equals 32. Okay, let's try it on the other side. 4 times 3, following rules of order of operations, we'll do multiplication first. 4 times 3 is 12, plus 4 times 5 is 20. 20 plus 12 equals 32. Same answer. So we can get the exact same result by distributing the 4 to each number inside the parentheses and multiplying, as we would by adding those two numbers together first and then multiplying by 4. So we will use the greatest common factor with the distributive property to solve problems such as this. Express 12 plus 20 as a product of the greatest common factor of the numbers and another sum. Let me walk you through this step by step. First, we find the greatest common factor of the two numbers. Use whichever method you prefer. I prefer method 3, so that's what I'm going to use here. So 2 is our least prime factor. That goes in 6 times and 10 times. Once again, 2 is our least prime factor, leaving us with 3 and 5. Oh, looks like I need to stop there. 3 and 5 are both prime. Okay, so our greatest common factor is 2 times 2, which gives us 4. All right, so I've completed step 1. Our greatest common factor of 12 and 20 is 4. Now let's go on to the next step. Our problem tells us to express 12 plus 20 as a product of the greatest common factor of the numbers and another sum. Okay, well, we have some keywords in here we need to pay attention to. Product means we're going to be multiplying. Sum means we're going to be adding. Okay, so we're expressing 12 plus 20 as a product of the greatest common factor of the numbers and another sum. Okay, so this is telling me I need my greatest common factor here. I'm going to multiply it by something, right? That's where product is coming in. So let's think about it this way. 12 is equal to 4 times 3. And 20 is equal to 4 times 5. Okay, so using distributive property, that means I can rewrite this problem as 4 times 3 plus 5. And there is our answer to this problem. Let me help you visualize this using a number line. So let's draw a number line that shows us that 12 plus 20 would work like this. Our first jump on our number line would be from 0 to 12. That represents our 12 quantity. Now if we add 20, we're going to jump up 20 places to reach 32, giving us a final answer of 12 plus 20 equals 32. Now let's look at this if we use 12 plus 20 as a product of the greatest common factor of the numbers and another sum. Now let's represent 4 times 3 plus 5 on the number line so we can visualize this. All we're saying in 4 times 3 plus 5 is that we're going to create 4 jumps of 3 plus 5. So let's begin with one jump of 3 plus 5, which takes us to 8. Another jump of 3 plus 5, which will take us to 16. Another jump of 3 plus 5, which takes us to 24. And finally, one more jump of 3 plus 5 to take us to 32. So no matter how we write the problem, if we write it as 12 plus 20 or as 4 times 3 plus 5, we get to the same endpoint, which is 32. Let's try another example that asks us to blend the greatest common factor and the distributive property. In this problem, we're going to express 18 plus 45 as a product of the greatest common factor and another sum. So our first step is to find the greatest common factor of 18 and 45. Again, use whichever method you prefer, but I would recommend you use prime factorization because it will make the process a little bit faster and more straightforward. So I'm going to use method 3 and compare 18 and 45 at the same time. First, we'll find the least prime factor of 18 and 45, which will be 3. 3 goes into 18 6 times, and 3 goes into 45 15 times. Do 6 and 15 share a least prime factor? Yes, they do. It's 3. 3 goes into 6 twice, and into 15 5 times. As 2 and 5 are both prime, we are finished. We've solved for our greatest common factor by taking 3 times 3 and getting an answer of 9. Now we move on to the next step, which is to rewrite 18 as a product of 9 and 45 as a product of 9. Well, 9 times 2 equals 18, and 9 times 5 equals 45. Now we use distributive property to change 9 times 2 plus 9 times 5 into a statement that expresses 18 plus 45 as the product of the greatest common factor and another sum. So we're going to pull our 9 out. We're going to put it here in the front. We're going to create an open paren. We're going to take this 2 right here, and we're going to move it right here. Bring down our plus sign. We're going to take the 5 from right here. We're going to place it right here. Close that paren, and here is our number sentence. 9 times 2 plus 5 is another way to express 18 plus 45 as a product of the greatest common factor and another sum. Basically, we are using the distributive property in reverse to create what's called a factored expression. Finish up today's lesson by trying these 3 problems on your own. For each pair of numbers, express the sum as a product of the greatest common factor of the numbers and another sum. This is a very long way to say you're going to factor this expression using the distributive property. Find the greatest common factor of each number, write it at the front of your equation. We're going to write that as GCF for greatest common factor. Then take whatever is left from the first number, add it to the second number, and put that inside your parentheses. Give these a try. We'll go over more problems like this together tomorrow. I know this is tricky, but give it a shot. Record your answers in your notebook, and we'll review them together tomorrow.